Good morning everyone. This is Dr. Manjula MV. Today I am going to give a presentation on a topic of anti-cancerous activity of green synthesized TiO2 nanoparticle. So my presentation includes contents like introduction, materials and methods, results and conclusion. Then next, coming to the introduction, so breast cancer is in a woman is the burning issue of this century. So despite of the chemotherapy and a magnetic therapy, some targeted by post chemotherapy is a great challenge. Thus, identifying the target specific drugs with the anti-cancerous potential without secondary complications is a challenging task for the scientific community. So, green technology has been employed in a greater way to fabricate the nanoparticles by amplifying the medicinally potential plants. So, thus the present study describes the synthesis of TiO2 nanoparticles using aqueous Tharana asiatica fruit extract and its anti-cancerous activity in MCF salines. So this includes some materials and methods like green synthesis of TiO2 nanoparticles, characterization of TiO2 nanoparticles. It includes XRD, FTIR, SEM, IDEX, TEM and as well as DLS, zeta potential. So coming to the pharmacological activity of TiO2 nanoparticle, we targeted on antioxidant activity, oxidative stress marker analysis, in vitro anti-inflammatory activity and anti-cancerous activity. So this slide represents synthesis and characterization of TiO2 nanoparticles. So figure 1 represents the characterization and extraction process of TiO2 nanoparticles by using Tharana asiatica fruit extract. And figure 2 represents a characterization results. Figure 2a, it's an XRD result and XRD analysis of TiO2 nanoparticle. Figure 2b, it's an FTIR results of synthesized nanoparticle. Here we compare the FTIR results with a plant extract that we are used for the synthesis. So figure 3a, it's an some image of TiO2 nanoparticles. It represents synthesized TiO2 nanoparticles are spherical in shape, and 3b, it's an histographic IDEX results and histographic analysis, and IDEX shows the purity of the synthesized nanoparticle. Then figure 4, it's an HR time image of the synthesized nanoparticle. Time represents the size of the synthesized nanoparticle, and figure 4b, it's an DLS results. It represents the dissolution factor, and zeta potential. Figure 4c, it's an zeta potential. It shows the negative charge and charge of the synthesized nanoparticle. Then this slide represents the antioxidant activity of synthesized TiO2 nanoparticle. So figure 5, it's an antioxidant activity of TiO2 nanoparticles against the DPPH scavenging agent. Here our sample shows promising results against the TiO2 nanoparticles, and compare with the ascorbic acid, it shows a significant results in a DPPH assay. So by this evidence, we further analyze this the synthesized nanoparticle by using NaNO2 induced oxidative stress RBC model with the oxidative stress parameters like LPO, PCC and total thiol content. So all these three parameter markers, our synthesized nanoparticle shows significant result and decrease in the level of LPO, PCC and as well as TT. Then figure 7 represents the antioxidant enzymes activity in the same NaNO2 induced oxidative stress. Here also our nanoparticle restores the activity of enzymes like SOD, superoxide dismutase and as well as catalase. So this slide represents the anti-inflammatory activity. Figure 8a, it's an inhibition study against the membrane inhibition study against the hemolysis activity. So here also TiO2 nanoparticles inhibits the hemolysis of RBC membrane. Then figure 8b and c represents the denaturation activity against the proteins like egg albumin and BSA. Compared to the aspirin, TiO2 nanoparticle shows significant and promising results against the denaturation activity, and we further analyzed using trypsin as an protease. Here also TiO2 nanoparticle shows a good result against the trypsin. So this slide represents the anti-cancerous activity of TiO2 nanoparticles. Figure 9a represents the cell viability status of TiO2 nanoparticle against the MCF cell lines. Here we used standard as an doxorubicin drug. Compared to the doxorubicin drug, our TiO2 nanoparticles also shows a good and promising result against the MCF cell lines. So figure 9b and c represents the again acrydyl orange at ethidium bromide staining, dual staining results. Here also it's an evidence for the it's an evidence for the analysis of TiO2 nanoparticle against the MCF cell lines. Here also against the MCF cell lines, TiO2 shows promising results. So this slide represents the evaluation of cell death propiondium iodide. So figure 10a, here we compare the cells using standard and as well as untreated and with a TiO2 nanoparticle. Compared to the standards, TiO2 also shows a promising results against the MCF cell lines. And this slide represents the micrographic representation of percentage of cells, and here also TiO2 gives an promising results compared to the standard drug. Then coming to the conclusion, the current study reports the green synthesized TiO2 nanoparticle using an Tharana asiatica fruit extract. TiO2 nanoparticle protects an RBC cells against the oxidative stress induced by NaNO2, and most importantly TiO2 showed an anti-inflammatory and as well as anti-cancerous activity. So it shows an TiO2 it's an good anti-cancerous and as well as anti-inflammatory agent. Then I would say thanks to my mentor Dr. Devraj S, Associate Professor, Department of Biochemistry, Tumkur University, and also thanks for YST for giving an opportunity to present my research work. Thank you so much. Thank you.